This lesson is differential equations. Now, differential equations will be all around us, okay? Well, yeah, sort of. Like, we'll do more than just this lesson, that's what I mean. So it's almost like it should be an introduction to differential equations. So we're going to work with differential equations of different orders, i.e. first, second, and so on. Okay, let's get straight into it. All right, here's an example, and it says, what order are these differential equations? Now, because this is the first derivative, it's first order, all right? So it's first order. This one, see how it's got a double derivative, so it's second, okay? This one, CC, it is not a differential equation because nothing has been differentiated. So we go not a differential equation. Now the next one is just written a bit differently. That's second order because it's a double derivative. So, all right. Okay, next one. Find the general solution of the following. So what we have to do is find, by integrating it, so we're going to have to do something first with A. I'm going to make y dash the subject. And now I need to integrate both sides to get my answer. So if I integrate this side, I get y, and if I integrate this side, I'm going to get x squared over 2 minus 3x plus c. Now I'm going to move this a little bit more to this side. Now obviously you can see that this will cancel out with that. So therefore the general solution is just y equals x squared minus 3x plus c. Now it's a general solution because the c can move it up or down in various directions and so on. I'm going to do the second one again. We need to make dy dx the subject. So let's do that. So we go dy dx equals x squared plus 4. And now I'm going to differentiate both sides. I'm going to show you something. I'm going to move the dx over to here. All right. So I've got dy equals bracket x squared plus 4 dx. So now I can integrate both sides. The integration of dy will just give me y, and then this one is just a normal integration with respect to x. So it's going to be x cubed on 3 plus 4x plus c. So that is the integral of this. And essentially, we've been playing around with this, but now I'm showing you more explicitly that we can, dy dx is an actual fraction that we can move around and it actually performs a function. All right, find the equation of the following given that this. Now, this should look familiar because it's the same as this one here. So what was the general solution? It was this. So I'm just going to grab it and copy it and paste it here so I don't have to do the work again. I do need to fix this up, all right. Oh, don't need to take away the plus c. Plus c. So we've got this one that we integrated it in the previous example, but we've got a little bit more information. We've got that it passes through 0, 4. So when x equals 0, y equals 4. So I can substitute that into this guy here. So let's do that. So 4, and then this is going to be easy because 0 plus c. Therefore, c equals 4. So it's just like motion where you're finding the plus c. Therefore, we've got this as equal to x squared minus 3x. And we actually know what the c is. The c is 4, plus 4. All right, so we're just playing around with a few different things. Let's go to the next one. All right, so this is going to be interesting. This used to be in a harder part of the course, but we'll see how we go now. So I'm going to have to differentiate this, okay? But the issue is this y thing here, all right? So I'm going to have to differentiate everything, okay? So I'm going to find the derivative of x squared, and I also need to do the derivative of y squared equals, and the derivative of a squared. Now, the derivative of just a constant is going to be 0, so that's really good. So this side's going to be 0. The derivative of this guy is going to be pretty straightforward because it's just going to be 2x, okay? Now, what about the following one? Well, I'm going to have to play around with, so I'm going to use a bit of space to explain it to you. So what I'm going to do is I'm going to use a chain rule over here, all right? So we need to do some sort of like a little chain rule. So what I'm going to do is use this. It's going to be d dy, all right? So we're going to derive something in terms of y. And then we can go dy dx, okay? So that way we can get rid of, like that crosses out and we're left with this thing over here, all right? But we need to apply it to y squared, so let's do it. So see how I'm going to write it, d dy of y squared. Now that's really good because I can differentiate with respect to y now. And then I'm left with dy dx, okay? So if I do this, I'm going to be left with 2y, because as we differentiate with respect to y squared, and then I'm left with, well, with this guy I have to tack it on, dy dx, all right? So that's what my answer will be here. I'm even going to write it the other way around, dy dx multiplied by 2y. Now, for it to be useful, I want to make dy dx the subject, so I'm going to move some things over to the other side. So I'm left with dy dx dot 2y is equal to negative 2x, and now I'm going to get therefore dy dx is equal to negative 2x on 2y. And obviously I can cancel these down. So if I rub out this bit here, which was my working outside, therefore dy dx equals negative x over y. Okay, so we can use differential equations even with when we've got x and y. All right, so have a look through that and see how you go. Peace out.